Time. It is the silent river that carries all things, the unseen current upon which existence drifts. We measure it with clocks, with calendars, with the slow turning of the earth and the steady pulse of our own hearts. To us, it feels stable, inevitable, an arrow that always flies forward. Without it, there is no memory, no story, no meaning. But what if this river is not eternal? What if the flow itself is fragile, capable not only of bending, but of breaking? At the edges of black holes, time slows almost to stillness, stretching seconds into eternities. In the quantum world, particles defy order, correlations leaping across space without concern for before or after. And in the accelerating universe, the distant future threatens a silence where time itself may lose direction. Everywhere we look, the cracks widen. Imagine standing at the boundary of reality, where cause no longer precedes effect, where tomorrow dissolves into yesterday, where the arrow of time fractures into chaos. What becomes of a universe when its most fundamental rhythm fails? What becomes of us, beings defined by memory and expectation, when the framework that holds past, present, and future begins to collapse? The question lingers, cold and unyielding. What if time itself is breaking down at the edge of reality? For most of human history, time was assumed to be absolute. The sun rose, shadows shifted, seasons turned, and death came as it always had. Time was the background, steady and impartial, against which all change unfolded. Isaac Newton gave this intuition its mathematical form. In his Principia, he described time as a universal stage, flowing uniformly for all observers, indifferent to the drama it contained. It was an invisible heartbeat of the cosmos, eternal and unchanging. For centuries, this view served well. Newton's mechanics guided ships across oceans, predicted eclipses, and explained the motions of planets. Time, simple and steady, needed no further thought. But by the 19th century, cracks appeared. The speed of light, measured with increasing precision, refused to bend to Newton's expectations. Whether a beam of light was chased or confronted, its speed remained constant. No stage, however eternal, could accommodate such defiance. The true fracture came with Albert Einstein. In 1905, with his theory of special relativity, Einstein declared that time was not universal at all. Clocks ticked differently depending on motion. A traveler moving near the speed of light would experience time more slowly than one at rest. In 1915, with general relativity, the fracture deepened. Gravity itself bent time, stretching and compressing its flow. A clock on a mountain peak ran faster than one at sea level. The eternal stage had collapsed. Time was not absolute, but elastic, a property of the fabric of space-time itself. The first evidence was subtle yet undeniable. In 1919, during a solar eclipse, starlight bent around the sun exactly as Einstein had predicted. The bending of space was also the bending of time. In the decades that followed, experiments piled upon each other. In the 1970s, atomic clocks flown on airplanes returned out of sync with their stationary twins. Today, the GPS satellites guiding phones and ships depend on constant corrections, compensating for both their speed and their altitude above Earth's gravity. Without relativity, our navigation would falter within hours. But perhaps the most unsettling discoveries came not from Earth, but from the cosmos. Around black holes, regions where gravity crushes matter into singularities, time appears to falter. Near an event horizon, seconds stretch into eternities. To a distant observer, an infalling astronaut would never quite cross the boundary. Their clock would slow, their movements freeze, their image fading into a timeless shadow. Inside, relativity predicts something stranger still. Time itself may end, its meaning dissolving in the singularity's infinite curve. This was the first true glimpse of time breaking down. Not metaphorically, not philosophically, but physically. A reminder that time was not eternal, but vulnerable. The paradox deepened when quantum mechanics entered the picture. At the smallest scales, particles seemed to defy temporal order. An electron could tunnel through a barrier instantly, as though time did not apply. Entangled particles influenced one another without regard for distance or sequence, correlations appearing outside the normal flow of cause and effect. To quantum mechanics, time was not sacred, it was negotiable. By the late 20th century, physics stood divided. Relativity described a universe where time bent with gravity, smooth and geometric. Quantum theory described a universe where time was uncertain, fragmentary, even optional. Both theories worked flawlessly within their domains, yet they spoke incompatible languages. And in that gap, the suspicion arose. Perhaps time itself was not fundamental. Perhaps it was emergent, an approximation, something that could falter, even collapse. Observations fueled the suspicion. Pulsars spinning neutron stars emitted beams of radio waves with clock-like precision. Yet their signals sometimes drifted when passing through regions of warped space, as though time itself wavered in the void. Gravitational lensing revealed light delayed and distorted, not merely bent, but stretched in ways that suggested time's elasticity was more fragile than theory allowed. And the accelerating expansion of the universe raised darker questions still. In the far future, would time retain its arrow at all? Or would it dissolve into thermal equilibrium, a timeless haze where nothing more could happen? The moment of discovery, then, was not a single experiment but a cascade. From Einstein's clocks to black hole horizons, from atomic oscillations to cosmic accelerations, the evidence mounted that time was not absolute. It bent, slowed, stretched, and perhaps at the edge of reality it could shatter. For humanity, the shock was profound. To realize that time, the very thing that carries thought, love, and memory, was unstable, was to realize that existence itself was more fragile than ever imagined. If time was fragile, then black holes became the laboratories where this fragility was exposed with merciless clarity. John Wheeler, who coined the very term black hole, often described them as the most perfect objects in the universe. They had no hair, no imperfections, no individuality, and yet they harbored the deepest paradoxes ever conceived, for they seemed to erase not just matter, but the very notion of when. At the event horizon, time behaved as though it were stretched across an infinite chasm. For a distant observer, the fall of an object into the hole would take forever. To the object itself, the fall would be swift, unremarkable. Two truths, mutually exclusive yet equally valid. This was the first hint that time was not a single river, but a fractured stream, branching depending on perspective. Stephen Hawking's insights in the 1970s deepened the riddle. By applying quantum mechanics to black hole horizons, he predicted that black holes were not eternal. They emitted faint radiation, now called Hawking radiation, and would eventually evaporate. But if the radiation carried no information, then time's arrow seemed to break. Events inside the black hole would be erased from the future, as though parts of reality were written in vanishing ink. This became the infamous information paradox, a wound in physics that remains unhealed. To solve it, some physicists speculated that time inside the black hole did not merely slow it, cease to exist altogether. Others argued that quantum entanglement stitched space-time together, and that losing entanglement across the horizon was like ripping the threads of time itself. In both visions, the message was the same. At the edge of black holes, time became unstable, inconsistent, perhaps even optional. Meanwhile, on the largest scales, cosmology began whispering a similar warning. The discovery in 1998 that the expansion of the universe was accelerating shocked astronomers. Dark energy, a mysterious pressure in the vacuum, was driving galaxies apart faster and faster. The consequence was unsettling. If expansion continued indefinitely, then in the far future, galaxies would drift beyond one another's horizons. No light would bridge the gulfs. The universe would dissolve into isolated islands, each alone in silence. In such a future, time's meaning itself might unravel. The arrow of time, defined by increasing entropy, depended on the existence of change. If galaxies faded, stars died, and energy spread thin, the universe would reach heat death, an eternal equilibrium where no further distinctions could be made. Time, once measured by change, would lose its markers. It would not stop, but it would cease to matter. By the early 21st century, new tools gave sharper glimpses of this fragility. Gravitational wave detectors, such as LIGO and Virgo, listened to the tremors of space-time itself. In 2015, they caught their first whisper, two black holes colliding in the distant universe. The waves that reached Earth were not merely distortions of space, but of time, stretching and squeezing seconds as they passed. Humanity had heard the ticking of the universe's most violent clocks, and they ticked irregularly, like drums echoing in a fractured hall. X-ray telescopes, too, probed the maelstrom near black holes. They revealed matter orbiting at incredible speeds, so fast that time dilation became measurable. To the gas spiraling inward, moments stretched longer than they should, as if the clockwork of the universe was faltering at the rim of the abyss. Even cosmic surveys showed anomalies. Regions of space appeared emptier than models predicted. Vast voids where galaxies should have been. Some of these might be statistical flukes, others the scars of dark energy at work. But whispers grew among theorists. Perhaps these voids were more than absences. Perhaps they were domains where space-time itself was thinning. The flow of time disrupted in ways beyond current equations. Through all of this, one theme endured: awe. Not fear in the ordinary sense, but a deep, existential awe at the possibility that reality itself might be incomplete. That time the fabric on which memory and meaning depend could falter, like a thread unraveling in a cosmic loom. Einstein had warned of such limits. In the field equations of relativity, singularities were not errors, but consequences. They signaled places where the theory surrendered, where its predictions failed. Hawking took this further, showing that singularities were not rare accidents, but inevitable, baked into the dynamics of gravity. If so, then the breakdown of time was not an edge case, but a fundamental feature of the universe. For scientists in the 20th and 21st centuries, this was both a revelation and a burden. The deeper they peered into the cosmos, the more they saw evidence that time was not what it seemed. Atomic clocks that disagreed, light signals delayed, gravitational waves stretching seconds, black holes consuming causality, all whispered the same unsettling truth. And so the paradox was born. Time was both real and not real, both fundamental and fragile. It guided every human heartbeat, every planetary orbit, every galaxy's dance. Yet under extreme conditions near horizons, at singularities, in the distant future, it seemed to break down, to dissolve into something else. The moment of discovery, then, was not a single flash, but a dawning. It began with Einstein, continued with Wheeler and Hawking, deepened with telescopes and detectors, and now rests on the edge of every new observation. Humanity has glimpsed not only the bending of time, but the possibility of its collapse. And in that realization lies the haunting question that threads through all physics. If time can break, what remains of reality when it does? Time had once appeared unshakable, the most faithful companion of the cosmos. From the rotation of the Earth to the orbit of the planets, from the burning of stars to the ticking of atomic clocks, its rhythm seemed absolute. Yet as the 20th century unfolded, physics began to peel back layers of reality that few had imagined could ever be disturbed. It was as though the universe itself was whispering that the clockwork was not perfect, that beneath its steady pulse, there were fractures forming. The first of those cracks emerged from Einstein's theory of relativity. In 1905, special relativity shattered the illusion of a universal shared time. Each observer carried their own clock, ticking at a rate dependent on their velocity. A train rushing past a platform did not merely move through space, it moved differently through time. To the passenger, the minutes passed as usual. To the watcher outside, those minutes stretched into something longer, softer, and stranger. Time, Einstein revealed, was not an objective stage upon which events unfolded. It was elastic, bending to the will of motion itself. A decade later, general relativity extended that truth. Gravity, Einstein discovered, was not a force pulling on objects, but a warping of space-time. And in that warping, time itself can slow. Near a massive star, seconds slipped by more reluctantly than in the quiet of interstellar space. Near the brink of a black hole, time stretched toward infinity. The closer an object moved to the event horizon, the more its clock seemed to pause. A falling star could vanish into darkness in its own moment, yet to distant eyes its collapse would appear frozen, forever unfinished. For the first time, scientists realized that time could not be trusted. It could dilate, curve, and even nearly halt. And if it could do these things, what guarantee was there that it would not break? The suspicion deepened as the century advanced. In the 1960s and 70s, black holes shifted from exotic curiosities to undeniable realities. John Wheeler spoke of them not just as collapsed stars, but as one-way membranes, where the distinction between inside and outside dissolved. Stephen Hawking later showed that black holes were not truly silent. They radiated faint whispers of energy, eventually evaporating into nothingness. But this revelation carried a deeper paradox. If a black hole destroyed information, then the very logic of cause and effect would collapse. Without information, how could the past guarantee the present, or the present guarantee the future? In that paradox, physicists glimpsed something terrifying. Perhaps time itself was not immune to destruction. The cracks spread further in the quantum realm. Quantum mechanics had long mocked classical notions of predictability, replacing certainty with probability. But it was in the phenomenon of entanglement that time's authority seemed to fray the most. Two particles, born together, could remain linked across vast distances. A measurement on one determined the state of the other instantly, no matter how far apart they drifted. Einstein himself called it spooky action at a distance because it ignored the universal speed limit of light. Yet more than just speed was at stake. Cause and effect themselves seemed to blur. If one particle's fate was tied to another's in an instant, was there truly a before and after between them? Or had the arrow of time bent into something circular, even meaningless? Experiments in the late 20th and early 21st century confirmed these suspicions. Entangled photons exchanged correlations faster than any signal could travel. To many, it suggested that time as a sequence of cause leading to effect was not as solid as once believed. The cosmic clock did not tick in perfect order. Instead, at its quantum gears, events unfolded in tangled simultaneity. Meanwhile, cosmology was unveiling an even more unsettling truth. In the late 1990s, the discovery of dark energy shocked the scientific world. The universe was not only expanding, it was accelerating. Galaxies were fleeing from each other faster and faster, pulled apart by an unknown force. This acceleration implied that in the far future, distant galaxies would slip beyond reach, their light stretched until it could never arrive. Beyond those horizons, time itself might take on new and broken forms. For in a universe rushing apart, the definition of now becomes slippery. One observer's present drifts irreparably away from another's. The cosmic clock does not just tick, it fractures into countless unaligned moments. As telescopes mapped these accelerating voids, some scientists began to wonder if the emptiness was more than absence. Could there be regions of the universe where space-time itself was tearing, leaving behind domains where time ceased to behave at all? Surveys of galactic distributions revealed strange cold spots, voids far emptier than models predicted. Some dismissed them as statistical flukes. Others whispered that they might be the signature of physics breaking down. The awe these discoveries inspired was mingled with fear. For the first time, humanity stood at the threshold of realizing that time, the very fabric upon which all existence depended, might not be eternal. It might be conditional, fragile, even temporary. If black holes could freeze it, if quantum entanglement could blur it, if cosmic expansion could scatter it, then perhaps the universe's most familiar companion was already unraveling. And if cracks had already appeared, what would happen when they widened? By the dawn of the 21st century, new tools were being sharpened to probe these mysteries. Gravitational wave detectors began to listen for the ripples of colliding black holes, offering a way to test time itself at the edges of catastrophe. X-ray telescopes peered into the hearts of galaxies, where matter spiraled toward horizons and time slowed to silence. Particle colliders smashed matter into fragments, searching for clues in the brief moments when quantum rules overpowered classical order. Each new instrument revealed the same haunting pattern. The deeper scientists looked, the less trustworthy time became. In lecture halls, in research papers, and in midnight debates among physicists, the same thought crept like a shadow. Perhaps time is not fundamental at all. Perhaps it is an emergent illusion, a byproduct of deeper laws that do not need it. If so, then the cracks in the cosmic clock were not signs of failure, but glimpses of a reality beneath time, a reality we are not yet equipped to comprehend. The stage was set, the silence deepened, the cosmos had shown its fractures. The question was no longer whether time could break, but how, and when, and what would remain once it did. The suspicion that time could fracture did not remain in the realm of theory. The more humanity refined its instruments, the more anomalies appeared, hints that the clockwork of the universe was not as smooth as once believed. One of the earliest shocks came from pulsars, the dense remnants of exploded stars that beam radio waves like cosmic lighthouses. Their rotations are staggeringly precise, rivaling atomic clocks in their stability. And yet, in certain instances, pulsars have been observed to glitch, suddenly changing their spin rates in ways that defy explanation. For some, these glitches were merely quirks of neutron star interiors. For others, they were warning signs. Perhaps deep within these collapsed remnants, time itself had stuttered. Then came the revelations from gravitational wave astronomy. In 2015, detectors captured the first whispers of space-time ripples from merging black holes. The event confirmed Einstein's century-old prediction, but it also raised darker possibilities. If space-time could ripple like water, what happened when those waves collided or interfered? Could they create regions where the usual flow of moments was disrupted, stretched into silence, or compressed into chaos? Some models even suggested that near the violent fusion of two horizons, time could briefly break, fragmenting into intervals too short, too twisted, for ordinary physics to describe. These ideas were unsettling, but it was at the frontier of cosmology that the deepest fears emerged. The cosmic microwave background, the faint afterglow of the Big Bang, has been studied for decades as a near-perfect map of the early universe. Yet, within its grainy pattern lie oddities, cold spots, asymmetries, and statistical imbalances that resist easy explanation. A minority of cosmologists propose that these anomalies might be scars, imprints of regions where space-time itself is imperfect. If true, they could be the fossil evidence of cracks in the cosmic clock, preserved since the birth of the universe. Quantum theory only deepened the unease. In laboratories, experiments with supercooled atoms created bizarre states of matter, Bose-Einstein condensates, where particles merged into a single quantum entity. Within these strange materials, researchers observed behaviors that suggested time symmetry could spontaneously break. Systems that should oscillate steadily instead developed preferred directions, as though time had quietly chosen sides. To some physicists, this hinted that time's arrow, the flow from past to future, might not be a universal rule, but a fragile emergent property, one that could fail under the right conditions. Even more startling were the whispers from particle physics. In the decay of certain subatomic particles, tiny asymmetries emerged, violations of CP symmetry, where matter and antimatter behaved differently. These violations were not just curiosities. They suggested that the laws governing time were not perfectly balanced. If the universe itself contained a bias, a flaw written into its foundations, then perhaps the cracks in time were not anomalies at all, but inevitabilities. The philosophical implications were staggering. Time had always been the invisible stage on which reality played its drama. But if the stage itself was warped, biased, or capable of collapse, then the entire performance of existence was in jeopardy. Could events occur without sequence? Could cause and effect unravel into nonsense? If time broke, would reality itself fragment into incomprehensible shards? These were not idle musings. As the 21st century advanced, theories at the bleeding edge of physics began to confront the possibility directly. Some models of quantum gravity proposed that space-time was granular, composed of tiny, indivisible units, atoms of space and time. If so, then time might not be continuous, but pixelated. And like any structure built from pieces, it could fracture under stress, near singularities, near the violent edges of black holes. Those grains might shatter, leaving behind domains where time had no meaning at all. Other theories suggested that time itself was emergent, an illusion woven from entanglement and correlation. In this view, the universe at its most fundamental level is timeless, a vast, static structure of possibilities. What we call time arises only when we, as observers, trace paths through that structure. If this is true, then cracks in the cosmic clock are not failures of physics, but glimpses of the deeper timelessness beneath. When anomalies appear, glitches in pulsars, voids in surveys, paradoxes in black holes, they are reminders that our sense of flow is not absolute, but contingent, fragile, and temporary. As unsettling as these ideas are, the awe they inspire is undeniable. To confront the possibility that time itself can fail is to stand at the edge of the greatest mystery ever conceived. For time is not just a coordinate, it is our existence. Without it, we cannot speak of past or future, of memory or hope, of birth or death. Without time, meaning itself dissolves. And yet, the universe seems determined to challenge us with this very possibility. From the freezing of clocks near black holes to the simultaneity of entangled particles, from the accelerating expansion of space to the anomalies etched in the microwave background, the message is the same. The cosmic clock is not unbreakable. Its ticking is a song that can slow, fracture, or fade. Scientists push forward, compelled by both terror and wonder. New generations of detectors, gravitational wave observatories, neutrino telescopes, quantum computers promise to probe deeper into the fractures. Each experiment is a question cast into the void. Will time hold, or will it finally betray us? For now, the cracks remain faint. The clock still ticks, and our lives proceed in their fragile rhythm. But in the shadows of black holes, in the silence of cosmic voids, in the flickering probabilities of the quantum realm, the suspicion grows. Time is not eternal. It is not perfect. It may not even be real. And if the cracks continue to spread, then one day, perhaps at the very edge of reality itself, the clock will finally stop. For centuries, light was considered the most faithful messenger of the cosmos. It raced through the void at an immutable speed, carrying with it the stories of distant galaxies and the secrets of stars long dead. To follow light was to follow truth itself, for nothing could outrun it, nothing could obscure its tale. Yet in the 20th century, the first whispers arose of a paradox, that there might exist places in the universe where even light could vanish, where the messenger itself was silenced, erased by realities too strange for human imagination. The seeds of this paradox were sown in the equations of Einstein. His general theory of relativity described gravity not as a force, but as the curvature of space-time itself. In this new vision, light could be bent, slowed, even trapped by extreme distortions. The mathematics allowed, almost reluctantly, for regions where the escape velocity exceeded that sacred constant, the speed of light. These regions would become known as black holes, though the term itself would not enter popular imagination until John Wheeler spoke it aloud decades later. At first, Such entities seemed absurd. The fever dream of equations stretched too far. Even Einstein himself doubted their physical reality. How could nature permit such monstrosities, regions from which no signal, no information, no photon could ever emerge? And yet, as the century advanced, evidence mounted. Stars orbited invisible companions at breakneck speeds, their dance betraying the pull of something immense yet unseen. X-ray emissions flickered from the hearts of galaxies, feeding on matter falling into invisible abysses. One by one, the universe confessed. Black holes were not fantasies. They were facts. But with their reality came deeper paradoxes. For if light could vanish, what then of the information it carried? Was it truly destroyed, or hidden behind a horizon beyond reach? This was no idle question. In the 1970s, Stephen Hawking's calculations revealed an even stranger twist. Black holes were not perfectly black. Through subtle quantum effects near their horizons, they could radiate, slowly evaporating over time. The paradox sharpened. If a black hole could vanish entirely, what happened to the information it had consumed? Physics demanded conservation, but the equations whispered otherwise, that information might be lost forever, consumed by the silence where even light could not return. This became the infamous information paradox, a puzzle that tore at the heart of modern physics. To resolve it would require reconciling quantum mechanics and relativity, the two great pillars of science that stood stubbornly apart. Quantum theory insisted information could never be destroyed. Relativity painted horizons of absolute darkness. Between them lay a paradox as deep as any the human mind had ever faced. Observations only deepened the enigma. The Event Horizon Telescope, linking radio observatories across the Earth, unveiled the first shadow of a black hole in 2019. It was not a simple circle of emptiness, but a dynamic, flickering ring of fire surrounding a darkness no eye could penetrate. Light circled and twisted around the horizon, bent into impossible orbits, before being swallowed whole. To gaze upon that image was to confront the reality of vanishing light, not as metaphor, but as photograph. And yet, in recent years, stranger signals have emerged. Astronomers studying galactic centers have reported flares of radiation that seem to echo after disappearing, as though light itself is attempting to escape the pull of the abyss, breaking free in desperate bursts. Some models predict that black holes could allow small leaks of information, subtle signatures written into the Hawking radiation itself. Others suggest that what appears to vanish may in fact tunnel into alternate descriptions of space-time wormholes, baby universes, or quantum firewalls that guard the horizon. Every possibility unsettles. If light can vanish completely, then the principle of conservation, one of the deepest laws of nature, is violated. If instead it is preserved but hidden, then reality is stranger still, storing information in ways beyond our comprehension. In either case, the paradox forces a reckoning. The universe may not obey the neat rules we once believed. For many scientists, the paradox of vanishing light is not merely about black holes. It is about the fragility of knowledge itself. Light is how we know anything beyond our own sky. Every star, every galaxy, every memory of cosmic history is inscribed in photons that reach our telescopes. To imagine a place where that record is erased, it's to imagine the limits of knowing, a frontier where human understanding collapses. But there is also awe. To stand at the edge of a paradox is to stand at the edge of discovery. Hawking's paradox became not a dead end, but a beacon, guiding generations of physicists to search for a theory that unites the quantum and the cosmic. Each failure to resolve it is also a reminder. The universe guards its deepest truths fiercely, revealing them only to those willing to confront impossibility itself. In this way, the paradox of vanishing light is both a warning and an invitation. A warning that our current laws may not be final, that even the most trusted messenger can be silenced, and an invitation to imagine what lies beyond, in the silence where light is gone, but reality remains. The search continues, across observatories and chalkboards, across simulations and thought experiments. For somewhere in the depths of this paradox may lie the key to a deeper truth, not only about black holes, but about time, space, and the fabric of existence itself. And if light, the purest thread in the cosmic tapestry, can vanish, then perhaps everything we take as permanent is already fragile, already slipping into an abyss beyond understanding. The paradox lingers like a shadow, haunting both science and philosophy. For in the end, the question is not merely about physics. It is about what it means to know. If the universe contains regions where even knowledge disappears, then perhaps the ultimate mystery is not out there among the stars, but here in our fragile confidence that light will always tell us the truth. If light can vanish, then the very act of observation, the cornerstone of science, comes into question. For centuries, the cosmos revealed itself through photons, obedient travelers across unimaginable distances. Yet black holes mock this trust. They raise the terrifying possibility that nature can hide its truths forever, not merely behind distance, but behind horizons that no knowledge can pierce. This realization has reshaped the philosophy of science itself. In earlier centuries, mysteries were assumed temporary. Once we built a better telescope, once we refined our equations, the veil would lift. But in the case of black holes, the veil is absolute. No matter how powerful the telescope, no matter how refined the detector, the interior of a horizon remains sealed. To know what lies within is not simply beyond our technology. It may be beyond the structure of reality itself. And yet, physicists refuse surrender. The paradox of vanishing light has become an engine of creativity, spurring theories that stretch the imagination. Some suggest that information is smeared across the surface of the horizon, encoded in microscopic degrees of freedom, a principle now called holography. In this vision, the three-dimensional world inside a black hole is nothing more than a projection of data inscribed on its two-dimensional boundary. Light does not vanish completely. It is stored like an encrypted archive upon the edge of darkness. Others envision firewalls, blazing curtains of quantum energy at the horizon. If such structures exist, they would annihilate anything that dared to cross, preserving information in a violent burst before it disappears. But this idea carries its own contradictions, challenging the principle of relativity that nothing unusual should mark the horizon itself. To accept firewalls is to rewrite the nature of space-time, a price many physicists hesitate to pay. Still more daring are proposals of baby universes, self-contained realms, budding from black holes, carrying away information into hidden branches of the cosmos. If true, then every vanishing photon might not be lost, but reborn elsewhere, continuing its story in a universe we will never see. In this vision, black holes are not graves, but wombs, creators of new realities sealed from our own. Each proposal attempts to answer the same haunting question: can knowledge truly vanish, or must it, in some form, endure? Meanwhile, astronomers continue to probe the paradox from the edges. Gravitational wave detectors like LIGO and Virgo have recorded the tremors of black hole collisions, ripples in space-time itself. These signals, faint as whispers across the void, provide a rare glimpse into horizons in motion. Some theorists suggest that hidden in these vibrations could be signatures of new physics, tiny deviations from Einstein's predictions. Perhaps evidence that light and information are not as lost as we fear. X-ray telescopes add their own clues, capturing matter in its death spiral as it plunges toward oblivion. These emissions, flaring and flickering, sketch the last desperate moments before light disappears forever. Yet even here, anomalies appear. Some flares linger longer than models allow. Others vanish abruptly, as though consumed by mechanisms beyond our equations. The cosmos hints, provokes, but never fully explains. To the human imagination, the paradox resonates far beyond laboratories. The idea of light vanishing has long haunted myth and poetry. Ancient cultures spoke of underworlds where the sun was swallowed each night, of cosmic beasts devouring stars. In modern times, these metaphors find eerie echo in the scientific reality of horizons. We are reminded that our most primal fears of darkness, of silence, of the unknown, were not unfounded fantasies, but intuitions of truths waiting to be discovered. Philosophers see in the paradox a mirror of mortality. If light itself can vanish, what of memory? What of consciousness? Are we too doomed to be erased? Our stories extinguished like photons at a horizon? Or does the universe, in ways we cannot yet imagine, preserve every trace? Just as physicists debate information loss, so too do human hearts wrestle with the hope that nothing loved is ever truly gone. The paradox also challenges time. If information is lost, the arrow of time points to irreversibility, a cosmic forgetting woven into the fabric of reality. But if it is preserved, however hidden, then perhaps the universe is timeless, every event eternal in some unseen ledger. This tension between erasure and permanence makes the paradox not only a problem of physics, but a riddle of existence itself. John Wheeler, who coined the term black hole, once described them as the most perfect objects in the universe. With only mass, spin, and charge, they seemed almost simple. And yet from that simplicity emerges the most profound paradox in science. The disappearance of light, so ordinary a phenomenon at the horizon, reveals fractures in our deepest theories, cracks in the foundations of knowledge. Stephen Hawking, near the end of his life, proposed that information might not be destroyed after all, but scrambled in ways that would appear chaotic to us. In his vision, the paradox is not absolute loss, but absolute confusion. The data is still there, but forever unreadable. Like ashes after a fire, the record persists, but in a form no one could ever reconstruct. This compromise, unsettling as it is, offers a glimpse of resolution, a middle ground between annihilation and salvation. Today, laboratories of theory push ever further. String theory, loop quantum gravity, holographic dualities, each offers frameworks where the paradox might dissolve. None are complete, but all are steps toward a future where the silence of vanishing light is explained. The stakes are immense. To resolve the paradox would not only unify quantum mechanics and relativity, it would reshape our understanding of reality itself. revealing whether the universe is a place where knowledge endures or one where forgetting is written into its very bones. And still, the darkness waits. Every night, telescopes turn toward the galactic center, to the monstrous black hole Sagittarius A star. Every flare, every flicker, every ripple in gravitational waves is scrutinized for hints. Somewhere in that data may lie the key to the paradox, a signature that light does not truly vanish, but whispers across horizons in ways we have not yet learned to hear. For now, the paradox remains unsolved, suspended between loss and endurance, silence and echo. It is not merely a scientific puzzle, but a human one. To confront it is to confront our own fear of being forgotten, our hope of being remembered. In vanishing light, we see both the fragility of knowledge and the possibility of eternity. The chapter closes then, not with an answer, but with a question. When light vanishes into the abyss, does it truly die? Or does it wait in forms beyond our perception? The universe offers no reply. Only the darkness responds patient, unbroken, and absolute. Time is usually imagined as a silent river, flowing in one direction, carrying all things forward. We measure it with clocks, calendars, and the movement of planets. It feels absolute, the most trustworthy backdrop against which life unfolds. Yet at the edge of reality, near the horizons of black holes, in the earliest fractions of the Big Bang, this fabric of time begins to fray. What seemed unshakable bends, stretches, and in some cases, seems to break. Einstein's theory of relativity first revealed that time is not universal, but local. A clock on a mountaintop ticks faster than one at sea level. A satellite circling Earth experiences moments differently from those we feel below. These differences are tiny, measurable only with precision instruments, yet they prove a staggering truth. Time is woven into the geometry of space, inseparable from gravity itself. The stronger the gravity, the slower the flow. Nowhere is this more dramatic than at the threshold of a black hole. To a distant observer, an object falling toward the horizon appears to slow, its clock ticking more and more sluggishly. From afar, it seems to freeze in place, suspended forever on the brink of disappearance. For the traveler plunging inward, however, nothing unusual occurs until the end comes swiftly, catastrophically. Time itself has split into irreconcilable perspectives. Both are true, yet they cannot be reconciled in ordinary understanding. This fracture is not confined to black holes. Cosmology suggests that the universe itself began with a rupture in time's fabric. In the first instant after the Big Bang, the familiar flow of seconds may not have existed at all. Instead, time may have emerged gradually, like a pattern crystallizing from chaos. The laws we now treat as fundamental, the arrow of time, the march from past to future, may have been born alongside matter and space, not before them. Quantum mechanics complicates the picture further. At subatomic scales, particles do not evolve smoothly from moment to moment. Instead, they exist in superpositions, collapsing into definite states only when measured. Time in this domain does not flow like a river, but flickers like a restless flame. Some physicists argue that the universe at its deepest level is timeless, and what we call time is merely an emergent illusion, born from the way entangled particles interact. If this is true, then the fabric of time is not merely fragile, it is secondary, a construct layered atop a deeper reality. The implications are profound. the arrow of time that governs our lives, the distinction between cause and effect, could be artifacts of limited perception. At the edge of reality, those distinctions blur. Past and future intertwine, causality bends, and events can no longer be ordered in a single, universal sequence. Near the edge of time's fabric, paradoxes multiply. Consider closed time-like curves, solutions of Einstein's equations, where time loops back on itself. In such regions, an event could be both cause and effect of itself, tangled in a loop with no clear origin. Though such curves are mathematical curiosities, they force a deep question. Is time's fabric stable, or could it fold back, permitting the impossible? Physicists like Kip Thorne have explored these possibilities, sometimes half-serious, sometimes with genuine alarm. A universe where time can bend into loops would challenge the very notion of free will, rewriting causality into strange knots. Yet nature, so far, seems to conspire against such scenarios. Quantum effects, energy conditions, and cosmic censorship appear to forbid stable time loops, as though reality itself resists breaking its own chronology. And yet, whispers of fragility remain. The Hawking paradox of information loss implies that the laws of physics may not preserve the strict unfolding of cause and effect. If information can be destroyed, then the flow of time is not immutable, it can rupture, leaving gaps in the record of existence. Similarly, in theories of quantum gravity, space-time itself is not continuous but granular, composed of discrete units, like a woven fabric seen under magnification. At such scales, time may jitter, advancing in tiny leaps rather than a smooth glide. The consequences ripple outward into philosophy. If time can break down, what becomes of memory? Our very sense of self depends on continuity, on the assumption that moments accumulate in an unbroken chain. But if reality permits fractures, if the chain itself can split or dissolve, then identity becomes unstable. Perhaps what we call the self is no more enduring than a whirlpool in a stream, a temporary shape in a current that never pauses. This is why the edge of time's fabric captivates not only scientists, but poets, theologians, and dreamers. In myth, time's unraveling often marks the end of worlds, the twilight of the gods, the final apocalypse, the turning of cycles. In science, the same imagery returns, cloaked in mathematics and observation. When galaxies collapse into black holes, when entropy drives the universe toward heat death, when quantum uncertainty blurs the arrow of time, we glimpse echoes of these ancient visions. Modern experiments bring the edge closer to home. Atomic clocks, so precise they lose less than a second over the age of the universe, are now sensitive enough to detect time's differences across a single step of elevation. These instruments confirm Einstein's predictions again and again, revealing that time's flow is not absolute, but fragile, vulnerable to the subtlest changes in gravity and motion. Each confirmation is both a triumph and a warning. The fabric is not unbreakable. Theoretical physics now seeks a deeper union. Relativity shows how time bends with space. Quantum mechanics shows how it flickers with probability. But the two refuse harmony. Their clash suggests that at the edge of understanding, time may not exist in any familiar form. To reconcile them is to admit that what we call fabric may not be fabric at all, but a provisional map, like the outlines of a coastline seen through mist. The shore is there, but its true contours are hidden. The pursuit of this hidden structure drives the quest for a theory of everything. Whether through string vibrations, spin networks, or holographic correspondences, physicists search for the pattern behind the veil. Each attempt, whispers the same truth, that time, so central to our experience, may not survive in the final equations. At the ultimate edge, there may be only relations, correlations, timeless symmetries, and from these, the illusion of flow. If so, then the fragility of time is not a flaw, but a clue. It is an invitation to look beyond the surface, to imagine a universe where existence is not bound to clocks and calendars, but to deeper principles we have yet to name. At the edge of time's fabric, we do not simply find breakdown, we find possibility. If the fabric of time can stretch, bend, and perhaps even snap, what would it mean for the universe as a whole? The question is not just technical, it cuts to the heart of existence. For billions of years, time has given the cosmos its rhythm, the pulsing of stars, the orbits of planets, the growth of life, the fading of civilizations. Yet if time itself falters, then all these rhythms lose their foundation. Physicists turn to the most extreme laboratories in nature to seek answers. Black holes are one, but another lies in the early universe. In the first trillionth of a second after the Big Bang, conditions were so intense that our current laws break down. Space was inflating faster than light, quantum fluctuations were seeding galaxies, and time itself may not have flowed in any sense we recognize. Did it begin as a kind of frozen potential, only later cascading into the forward stream we inhabit? Or was it always flowing, but in a way fundamentally alien to human perception? Stephen Hawking once proposed a radical solution, the no-boundary hypothesis. In this vision, the universe has no edge in time. Just as Earth's surface has no boundary at the North Pole, it simply curves into another direction. The cosmos may curve away from a temporal beginning. Time, in its earliest form, could have been indistinguishable from space, a dimension without before or after. Only later did the familiar arrow emerge, giving rise to history, cause, and consequence. But even this elegant vision does not resolve the tension. If time can change its nature from spatial to temporal, from timeless to flowing, then its fabric is not fundamental. It is contingent, conditional, fragile. And fragility implies that under the right pressures, it could shift again. The possibility unsettles. If time is not absolute, then its breakdown might not be confined to the universe's birth or its most violent corners. Subtle cracks could ripple, even through the present, in ways too delicate for us to perceive. Some physicists wonder if quantum entanglement, where particles share connections across vast distances, is already a sign of time's fragility. Entangled particles appear to bypass the normal sequence of cause and effect, responding to each other as though distance and delay were meaningless. Could this be a glimpse of a deeper timelessness leaking through the fabric of the present? Others speculate that time may not flow smoothly toward infinity, but may end. In cosmological models, the universe faces several possible fates: eternal expansion into a cold heat death, a collapse back into a fiery crunch, or a violent tearing apart as dark energy accelerates everything beyond coherence. In each scenario, time's fabric strains. In heat death, the arrow loses direction, as all differences dissolve into uniform entropy. In the crunch, time could fold back into itself, erasing the future as it collapses toward a singular past. And in the tearing, time itself could lose continuity, ripped apart like parchment in a storm. What lies beyond such endings? Physics is cautious, but imagination is not. Some suggest that just as time emerged once, it could emerge again. A collapsing cosmos might give birth to a new beginning, its end folded into another birth, an eternal cycle of time's death and rebirth. Others dream of multiverses, where time flows differently in each domain, like varied currents in an ocean of existence. Perhaps our time is breaking at the edges, not because it is fragile, but because it borders other realities, each with their own rhythm. And yet, even as theories multiply, experiments bring the mystery back to Earth. In particle accelerators, collisions recreate conditions of the early universe, probing whether time's symmetry holds. In gravitational wave detectors, ripples from black hole mergers carry whispers of extreme temporal distortion. In precision labs, physicists test whether fundamental constants, the speed of light, the charge of the electron, remain steady, or whether they drift, hinting at cracks in time's foundation. So far, the cosmos remains stubbornly consistent, but the search itself is a reminder. The possibility of breakdown is not an abstraction. It is a frontier we are actively approaching. The human response to this frontier is complex. On one hand, the fragility of time evokes fear. If the foundation of existence can fracture, then nothing is secure. Memory, identity, progress, all may be illusions, temporary patterns on a shifting canvas. On the other hand, fragility brings wonder. If time is not fixed, then reality is not locked. It can change, evolve, surprise us. What seems eternal may be only provisional. What seems impossible may be waiting beyond the veil. This duality has always haunted human culture. Myths of the world's end often pair destruction with renewal. The Norse Ragnarok destroys the old order, but gives birth to a new one. Hindu cosmology imagines vast cycles of creation and dissolution, where time itself is reborn endlessly. Modern physics, for all its rigor, circles back to the same themes. A cosmos where time can break is a cosmos where endings and beginnings are not final, but part of a larger rhythm. Still, there is unease. If time is fragile, then our very perception may be unreliable. What we call now could be a construct stitched together by consciousness, a useful fiction. Neuroscience supports this. The brain does not perceive time continuously, but assembles it in fragments, integrating sensation with memory into a flowing narrative. If consciousness itself relies on illusions of continuity, then perhaps the breakdown of time is not just cosmic, but personal. At the edge of time's fabric, we find the edge of the self. The question then becomes not whether time will break, but whether we can live knowing it might. Science offers equations, experiments, and predictions. Philosophy offers frameworks of meaning. Religion offers visions of eternity beyond time. But all agree on one truth: the flow we take for granted is not guaranteed. It is a gift, a fragile inheritance, a story written on a fabric that may fray. And perhaps that is enough. Fragility does not mean failure, it means sensitivity. Time responds to gravity, to motion, to entropy, to quantum uncertainty. Its very vulnerability makes it rich, dynamic, alive. If time were absolute and unbreakable, the universe would be static, frozen. It is because time bends that stars burn, that galaxies form, that life arises. It is because time can break that new possibilities emerge. At the edge of time's fabric, then, we do not find only doom. We find creativity. The cracks are not just endings, but beginnings. They are places where the known dissolves and the unknown takes shape. Whether through cycles of universes, through the birth of timeless laws, or through the awakening of consciousness itself, the fragility of time is a reminder that existence is not finished. It is still unfolding, still writing itself, moment by moment. And so the chapter closes, not with despair, but with wonder. Time may be fragile, but so are we, and fragility is not weakness. It is the condition of being alive, of changing, of discovering. If the fabric frays, it is not the end of the story. It is the opening of another. Time has always been imagined as a river, unseen yet steady. Its waters carry every life, every galaxy, every memory downstream, in a ceaseless flow that cannot be reversed. But what if that river is not smooth? What if it trembles, hesitates, or even falters for a fraction of eternity? What if time itself stutters? This unsettling possibility is no longer confined to the realm of poetry or philosophy. It has crept into the very equations of modern physics, into experiments that disturb the foundations of causality, and into the experiences of human consciousness, which sometimes seems to glimpse cracks in time's steady march. To imagine a universe where time does not flow but quivers, pausing like a breath held in the dark, is to enter a domain where science brushes against the edge of metaphysics. This scientific principle behaves as we expect. One of the most haunting examples is called the quantum Zeno effect. It arises from a simple but unsettling principle. When a quantum system is observed repeatedly, its evolution slows or even stops altogether, like a candle flame frozen mid-flicker. The act of watching seems to hold the system in place. The idea was first explored in the late 20th century. Physicists discovered that if you measure a particle often enough, you can prevent it from changing state. The system hesitates, caught between its possibilities, suspended in a limbo that defies intuition. It is as if the universe itself cannot decide how to proceed until it is allowed a moment of privacy. Under constant gaze, time refuses to advance. This is no abstract speculation. Laboratory experiments with trapped ions and ultra-cold atoms have demonstrated the effect. Each time a measurement is made, the system's wave function, its haze of probabilities, collapses into a frozen state. Repeated often enough, the system remains locked, as though trapped in the blink of eternity. It is a physics experiment that feels like myth, the watched pot that never boils, not because of impatience, but because reality itself is altered by attention. But the quantum world has darker riddles still. Entangled particles, once connected, can influence each other instantaneously, even across vast distances. This already bends the notion of causality. But delayed choice experiments, first imagined by John Wheeler, take the paradox further. Imagine light passing through a pair of slits, forming an interference pattern that suggests it behaves like a wave. But if you decide, after the photon has already passed the slits, to measure which path it took, reality seems to rewrite itself. The photon behaves as though it always knew it was being observed, even retroactively. In these experiments, time itself stutters. The present decision appears to affect the past outcome. The arrow of time seems less like a line and more like a trembling thread, uncertain of its own direction. Physicists resist the temptation to speak of changing the past, preferring instead to say that quantum systems exist in superposition until measured. Yet the haunting impression remains that the timeline is not solid, that causality is fragile, and that time itself may hesitate before declaring what has already happened. If the quantum realm suggests hesitation, cosmology whispers something stranger, that perhaps time is not continuous at all. Some physicists speculate that time is composed of indivisible units, chronons, like frames in a film reel. To us, consciousness stitches these frames into fluid motion, just as the eye interprets 24 still images per second as cinema. But beneath the illusion, perhaps reality flickers. If so, then each moment of existence may be a frozen frame, separated by imperceptible gaps. Time, instead of a river, would be a sequence of stillness and motion, like the beating of a cosmic heart. And if that heart hesitates, even briefly, then reality itself would stutter. The implications are chilling. What we call continuity might only be memory's gift, smoothing the cracks between instants. If those cracks widen, if the pulse of time slows, we might feel it not as catastrophe, but as déjà vu, as a haunting repetition, as the uncanny sense that we are living the same instant twice. In the lives of individuals, such moments have long been whispered about. A soldier in battle who reports that the world slowed to stillness as bullets passed overhead. A survivor of an accident who recalls seeing entire scenes unfold in the space of a single heartbeat. The countless stories of déjà vu, when the mind insists that the present has already occurred. Science usually explains these phenomena as quirks of perception. Adrenaline alters neural timing, the brain misfires, memory overlaps. Yet what if they are shadows of something deeper, glimpses into the uneven pulse of time itself? Near-death experiences add another eerie layer. People describe life reviews compressed into seconds, or a sense of timelessness altogether, where eternity is folded into an instant. If consciousness depends on time, what does it mean that it can persist in the absence of its flow? Are these only illusions created by neurons starved of oxygen? Or are they cracks where the stutter of time reveals itself? If time hesitates, even briefly, the consequences for physics are profound. Relativity depends on the smoothness of spacetime. The equations of Einstein describe a fabric stretched but never torn. Quantum field theory relies on a steady rhythm of progression. Remove the flow, and the music of the cosmos risks collapsing into silence. Yet hesitation is not the same as destruction. A stutter is fragile, fleeting, but it hints at imperfection, and in physics, imperfection often opens the door to discovery. If the continuum is not continuous, then the universe may be more like a lattice, a hidden digital architecture beneath the analog illusion. If so, then perhaps time's stutter is not a flaw, but a signature evidence that we live inside a cosmic computation, that reality is coded, and that the pauses are the ticks of a clock deeper than space-time itself. To imagine time hesitating is to imagine the machinery of the cosmos itself missing a beat. Every orbit of a planet, every vibration of an atom, every thought in the human brain is synchronized to this unseen rhythm. If the rhythm falters even slightly, what happens to reality? Physicists sometimes describe the universe as a cosmic clock, ticking according to the laws of physics. Yet experiments have hinted that this clock may not be perfect. The search for time crystals, bizarre states of matter that repeat in time instead of space, suggests that temporal symmetry can break that motion itself, can freeze into repetition, like a pendulum that swings forever without using energy. Discovered in laboratories in the 2010s, time crystals are real physical objects where particles return to their previous states in perfect rhythm. They are not perpetual motion machines, but they defy the expectation that systems must eventually decay into disorder. Instead, they endure, locked in temporal stutters, repeating endlessly. If such crystals exist, could the universe itself be one? Could the entire cosmos be a vast, shimmering lattice of repeated instants, each one folding over the last in endless refrain? If so, then the stutter of time is not an error, but the very structure of existence. Nowhere is the possibility of broken time more terrifying than at the edge of a black hole. According to relativity, as matter falls toward the event horizon, an external observer sees it slow down. The clock ticks more and more sluggishly, until at the horizon it appears to stop altogether. To the outside universe, time itself seems to freeze at that edge. For the falling traveler, time still flows normally. They plunge inward, perhaps unaware of the cosmic hesitation around them. But for those left behind, the universe watches as reality itself pauses, as though stitched into the fabric of the horizon. This is not poetic speculation. It is mathematics. It is the inevitable consequence of curved spacetime. At the threshold of ultimate gravity, time stutters. Some physicists argue that this effect reveals a deeper truth, that black holes are not just regions of collapsed matter, but fractures in the rhythm of time itself. What lies inside remains hidden, perhaps not because of distance, but because the beat of time does not survive the crossing. If so, then every black hole is a wound in the timeline, a place where the music of existence falters and silence bleeds outward. Human beings have always been haunted by déjà vu, the eerie sensation that the present has already been lived. Neuroscience offers explanations: misfires in the hippocampus, memory glitches, short circuits between perception and recall. But what if déjà vu is not only neurological, but ontological? What if déjà vu is a perceptual echo of time itself hesitating? If the universe does flicker between frames, if time is discrete rather than continuous, then perhaps consciousness occasionally notices the overlap, a stutter where the same instant repeats. The brain interprets this as memory, as familiarity, but in truth, it is awareness of the slip in reality's reel. Ancient traditions often described time as cyclical. Hindu cosmology spoke of kalpas, great cycles where creation repeats. The Stoics imagined the eternal recurrence, where every event returns endlessly. Could déjà vu be the smallest echo of this larger truth, the rhythm of the cosmos whispering through our perception? The idea of stuttered time inevitably draws us toward one of the most audacious speculations of modern philosophy: the simulation hypothesis. If reality is computed, like software running on a cosmic machine, then perhaps the glitches we sense, déjà vu, temporal loops, hesitations at the quantum level, are signs of the underlying code. Just as a video game may lag when processing too much information, perhaps the universe hesitates when the complexity of events grows too dense. To live inside a simulation is to accept that time is not fundamental, but manufactured. Each second would not be a flowing river, but a rendered frame. And just as digital worlds sometimes freeze before resuming, perhaps the stutter of time is the trace of a deeper architecture. For many physicists, such speculation is unsatisfying, untestable, unprovable. Yet others argue that if we search carefully, we might find the lattice of reality itself, the smallest scales where smooth space-time breaks into pixels of duration. If we ever find those pixels, it will mean time truly does not flow, it ticks, and every stutter is a clue. Even if time flows flawlessly, human beings can never escape the fragility of their own perception of it. Memory creates continuity, stitching together isolated moments into a story of self. Without memory, each instant would be isolated, disconnected. Philosopher Henri Bergson once argued that time as humans know it is not measured by clocks, but lived through consciousness. Duration is not the same as chronology. To live is to swim in the flow of duration, not merely to count the seconds. But if consciousness is what weaves the stutter into smoothness, what happens when consciousness falters? In Alzheimer's disease, time collapses. In deep meditation, time dissolves. In dreams, seconds can stretch into hours. The stutter of time may not be only in the cosmos, but in the mind that perceives it. We are both victims and creators of time's flow. The stutter may be in reality, or it may be the mirror of our own fractured awareness. To accept the stutter of time is to abandon the idea of a flawless universe. It is to live in a cosmos where continuity is fragile, where existence trembles between motion and stillness. What does it mean for free will if the timeline itself hesitates? What does it mean for identity if moments repeat? Are we the same person in each frame? Or does each stutter birth a new self, indistinguishable but separate? Some philosophers imagine that in every hesitation of time, entire universes bloom. In one, the moment proceeds. In another, it halts. In another still, it doubles back. Infinity may not be stretched across the horizon, but hidden between the ticks of time itself. Perhaps the most haunting possibility is that time stutters not only now, but at the very end of the universe. Cosmologists debate the fate of the cosmos: endless expansion, collapse into fire, or slow heat death. But another possibility lurks, that the universe does not end with a bang or a whimper, but with a pause. A stutter that never resumes. The final hesitation. Every star frozen, every atom locked, every consciousness trapped in a single instant, an eternal stasis. Not the destruction of reality, but its endless stillness. A silence that echoes forever. If the river of time can hesitate, then nothing we take for granted is certain. Continuity is not guaranteed. Memory may not align with reality. Cause and effect may not always flow in one direction. And yet, perhaps it is this fragility that gives existence its poignancy. We live, love, and create in the pauses between stutters. We tell stories to give coherence to a trembling reel of instants. We search for meaning in a universe that may itself hesitate before answering. The stutter of time is not just a question for physics. It is the most intimate mystery of human life. For when time falters, even briefly, we glimpse what it means to exist at the edge of reality. At the very edge of what we call reality, there are places where mathematics itself begins to stutter. Equations that hold the fabric of the cosmos together start to fray, like old rope giving way under unseen weight. It is here, beyond the polished corridors of physics and into the trembling boundary of metaphysics, that we must ask, what if time itself is breaking down? What if the arrow of time, that quiet, relentless flow that carries us from birth to death, from memory into forgetfulness, is not eternal at all, but fragile, fractured, and already unraveling at the edges of the universe? The ancients never doubted the passage of time. For them, the rising of the sun and the falling of the moon were eternal assurances. But modern science, with its telescopes peering deep into the cosmic abyss, has shown us something far stranger. That the deeper we gaze, the less stable time becomes. Black holes warp it, near light speeds stretch it, and quantum particles defy its order altogether. Time is not the perfect river we once thought. It is a trembling lattice, full of cracks, ready to shatter when pressed. And yet, if we follow these cracks carefully, they lead us to the most unsettling frontier of physics, the possibility that time may not just bend, it may one day collapse. Imagine a tapestry being slowly unwoven, thread by thread. To the eye, it still looks whole, but from within, its structure is failing. That, scientists suggest, may be happening right now at the subatomic level. Entropy, the law of disorder, drives everything toward chaos. Stars burn, galaxies drift, memories fade. But entropy does not simply march forward. It may be signaling that time's very mechanism is breaking down, that the gears of the cosmic clock are grinding to a halt. What does it mean to stand at the edge of such a thought? To live in a universe where time itself is fragile? It means confronting the possibility that all of human history, every heartbeat and every shadow, is balanced precariously on a failing foundation. The laws that make sense of our lives are not eternal decrees, but temporary agreements in a cosmos that may not care for stability. Consider the physicists who first confronted this possibility. In the mid-20th century, researchers studying the expansion of the universe realized that time and space were not separate entities. They were fused, part of a single continuum space-time. Einstein had already bent our understanding by showing that gravity is not a force, but a curvature in this space-time fabric. But if gravity could bend time, what else could? What if deeper forces still unseen, still unnamed, could do more than bend it? What if they could break it? Quantum mechanics has given us glimpses of this strange possibility. At the smallest scales, time does not behave like the continuous line we imagine. Instead, it flickers, jumps, and hesitates. Some experiments even suggest that particles can borrow moments of time, existing in two states at once, defying causality altogether. If particles at the foundation of reality can step outside the flow of time, then the river itself is not steady. It is a turbulent current, with whirlpools and fractures, waiting to pull us into impossible directions. And so, cosmologists began to ask daring questions. Could there be regions of the universe where time is already unraveling? Perhaps near the event horizons of black holes, where time slows to a crawl. Or in the vast gulfs of intergalactic space, where the expansion of the cosmos is accelerating so violently that the normal sequence of cause and effect begins to lose meaning. Even the cosmic microwave background, the faint echo of the Big Bang, may hold evidence of distortions in the timeline of the universe. Hints that the earliest moments were not smooth, but broken. For us, anchored here on Earth, time feels solid, but perception is not reality. A goldfish in a bowl believes the glass walls are the universe until it is lifted out. Humanity, too, may be confined in a fragile frame of reference, unaware that beyond our sensory prison, time is crumbling. Our calendars, our clocks, our memories, all might be nothing more than the faint light of a firefly in the night, doomed to vanish when the frame holding it together collapses. The most chilling thought is this: if time breaks, reality itself may follow. For reality is nothing without sequence. Cause and effect, birth and death, thought and action, all depend on time's flow. Remove it, and everything dissolves into a meaningless simultaneity, an eternal moment where nothing changes and nothing can ever happen again. Physicist Carlo Rovelli once wrote that time is not a universal stage upon which events unfold, but a fragile web spun between interacting things. Break the web, and the play of existence ceases. This vision is not just scientific, but deeply philosophical. If time is breaking down, then our lives are not lines, but fragments, scattered across a collapsing mosaic. What we call now may not exist at all. It may be only the brief shimmer of a fading structure. The past may not be secure, the future may not arrive. And in the deepest corners of physics, researchers are already confronting mathematical signs that such a collapse is possible. One such sign is the concept of time's arrow. We only experience time moving forward because entropy increases. But if entropy one day reaches a maximum, time itself may lose direction. There would be no distinction between past and future, only a stagnant expanse of being. Some cosmologists believe the heat death of the universe, that final state where everything has decayed into uniform coldness, is precisely such a moment. Time would end, not with a bang, but with stillness, like a clock whose hands no longer move. And yet, even more radical theories suggest that before such an end, time may shatter into chaos, perhaps at the edge of black holes, or in the mysterious quantum foam beneath space-time itself. Reality already flickers with breakdowns in continuity. What we call laws of physics may be temporary scaffolding, destined to collapse like the ruins of forgotten civilizations. If so, then the true frontier is not space, but time itself. As we drift deeper into this unsettling thought, one question lingers like a whisper. What would it feel like to live through the breaking of time? Would seconds stretch into eternities? Would days collapse into moments? Would the stars freeze above us, locked in eternal light, while we fade into silence? Or would everything dissolve instantly, with no witness left to wonder what had been? The human mind recoils from such visions, and yet, at the boundary of science, they persist equations that stutter, experiments that defy causality, horizons that hide the collapse of order. Time, our most trusted companion, may not be the eternal guide we believed. It may be a fragile shadow, already breaking apart at the edge of reality. If the arrow of time were to fracture, we would face not only a scientific puzzle, but a profound existential crisis. For time is not merely a physical dimension, it is the very canvas upon which meaning is painted. To imagine its collapse is to imagine the collapse of narrative, of history, of self. What are we without the sequence of moments that makes us who we are? Without time, memory is stripped of coherence, choice of consequence, love of continuity. The very act of existing becomes incomprehensible. This is why scientists and philosophers alike tread carefully at this precipice. When they peer into the mathematics of quantum gravity, attempts to reconcile Einstein's relativity with the quantum world, they often find that time is not fundamental. It emerges like a shadow from deeper structures. Loop quantum gravity, for instance, suggests that space and time are quantized, broken into tiny, indivisible chunks. If this is true, then what we call flowing time is an illusion, a byproduct of these discrete steps. But illusions, no matter how convincing, can fail. And when they do, the illusion collapses back into the nothingness beneath. Physicist Julian Barbour has gone further, proposing that time does not exist at all. According to him, reality is a collection of nows, snapshots of the universe in different configurations. What we experience as the passage of time is simply our mind's way of linking these snapshots into a story. If Barbour is correct, then the breakdown of time is not a catastrophic event to come. It is already our reality. We live in fragments, And the story we tell ourselves is nothing more than a fragile trick of perception. Other models take us into even stranger territory. In certain versions of string theory, time may have multiple dimensions, folded and hidden beyond our perception. If one of these dimensions were to collapse or unravel, the flow of time in our universe could be distorted, fractured, or even reversed. Imagine living in a reality where some regions move forward in time while others run backward, or stand frozen in eternal stillness. To cross such a boundary would be like walking from a living world into a mirror, one where cause and effect are scrambled, where memory precedes experience. The closer we look at the universe, the more evidence we find that such boundaries may not be mere speculation. In the deepest observations of the cosmos, astronomers have detected galaxies that seem to rotate in patterns defying standard models. Some theorists suggest this may be evidence of time domains, regions where the fundamental direction of time differs from our own. If true, then the cosmos is not uniform in its flow of time, but fractured, divided, and unstable. And yet, the greatest proof of time's fragility lies within us. Neuroscience has shown that our brain does not experience time continuously. Instead, it pieces reality together in small intervals, frames stitched into the illusion of a film. This means our perception of time already flickers, just as the universe itself may flicker. When we meditate, when we dream, when we slip into moments of timeless awe, we touch the fragile threads holding time together. Perhaps these are hints not of psychological tricks, but of the deeper truth that time is not what it seems. But what would the collapse of time mean for the universe itself? Cosmologists imagine several possibilities. One is the so-called Big Freeze, where the expansion of the cosmos stretches everything so far apart that no interaction is possible. Without change, without interaction, time loses its meaning. Another is the Big Rip, where expansion accelerates so violently that space-time itself tears apart, shattering time along with space. In both scenarios, time ends not with a single event, but with the slow erosion of meaning, the story of reality losing its coherence, page by page, until no book remains. There is, however, an even stranger possibility, that the breakdown of time might give birth to something new. In cyclic models of the universe, time collapses not into silence, but into renewal. Each universe ends in temporal collapse, only for a new one to emerge, with its own arrow of time, its own history, its own possibilities. In this view, the breakdown of time is not the end, but the beginning, a cosmic heartbeat that pulses eternally, each collapse giving rise to another dawn. Still, the question remains, what would it mean for us? If time collapses tomorrow, would we feel it? Would we notice the stutter, the flicker, the fracture? Or would we simply dissolve into silence, our final thought cut short, with no awareness that it had ended? This is the haunting paradox. To witness the death of time requires time. To experience its breakdown is impossible, for the very act of experiencing depends on it. We may speculate, we may model, but if time dies, no one will be left to tell the tale. And yet, in a way, we already live in fragments of such collapse. Think of moments when memory slips, when we forget what we were about to say, when dreams blur into waking, when seconds vanish unnoticed. These are tiny cracks, personal collapses of time, hidden in the folds of our daily life. Perhaps the universe itself is no different, fraying moment by moment, dissolving at the seams, and we are too close to see it. To accept this possibility is to confront our own fragility. It is to see ourselves not as eternal beings marching forward on an infinite line, but as brief patterns in a fragile fabric. Our lives are like ripples in water, visible for a moment, then gone, leaving only the trembling of the pond. If time itself is breaking, then even the pond is fading. There will be no ripples, no water, no witness, only silence. And yet silence is not nothing. In the stillness beyond time, perhaps something lingers. Perhaps the end of time is the beginning of timelessness, a state we cannot imagine, but that cradles us nonetheless. Some philosophers have speculated that consciousness itself may not depend on time. If that is true, then the breakdown of time may reveal not an end, but a truth, that we were never truly bound by time at all, only fooled by its flow. The cosmos may be fragile. Time may be unraveling. Reality itself may be balanced on the trembling edge of collapse. And yet, here we are, speaking, breathing, wondering. Perhaps that is the deepest mystery. Not that time is breaking, but that within its fragile shadow, beings like us can look at the stars and ask why. For as long as the clock ticks, as long as the seconds march forward, we will wonder. And when it stops, if it stops, perhaps that final question will remain. Echoing at the edge of reality, unanswered yet eternal, what if time itself was only ever an illusion, already broken, even as we lived within it? At the edge of human understanding lies a terrifying possibility. What if time itself is not eternal, not stable, not even fundamental, but instead fragile, breakable, and already cracking beneath the weight of reality? We live as though tomorrow is promised, as though seconds stretch endlessly into the future. But physics whispers another story, that time may be faltering, like a thread fraying at the seams. To listen to this whisper is to step into a place where cause and effect blur, where memory loses its anchor, where the universe itself may not last as long as we imagine. For centuries, time was considered absolute, a backdrop against which existence played out. Isaac Newton described it as a river, flowing steadily, independent of what happens within it. But Einstein shattered this vision. In his theory of relativity, time is not separate from space, but interwoven with it, warped by gravity, stretched by velocity. This was the first fracture in our certainty. Time was no longer universal. It bent and twisted, different for each observer. If two people are separated by vast gravitational fields or moving at different speeds, their clocks will tick at different rates. Time itself had become pliable. But relativity is only the beginning. As physicists looked deeper into the quantum world of atoms and particles, they discovered something stranger. In quantum mechanics, particles exist in superpositions, hovering between states until measured. Time in this realm is slippery, uncertain. Equations that govern quantum reality don't require a now. They describe possibilities, probabilities, patterns, but not the steady march of seconds. This raised a chilling question. If the deepest laws of physics do not contain time, is time real at all? Or is it just a construct of human perception, stitched together by memory and expectation? One of the most unsettling possibilities comes from the study of entropy. The second law of thermodynamics tells us that entropy disorder always increases in an isolated system. It is this increase that gives time its arrow. A cup shatters on the floor. We never see shards reassemble into a cup. A candle burns. The wax and smoke never leap back into flame. The future is defined by growing disorder. Without this law, time loses its direction. But what if entropy itself falters? What if the arrow of time bends, or worse, breaks? Then the past and future would blur into one, and the very structure of existence would collapse. Cosmologists have long suspected that such breakdowns could occur at the most extreme edges of the universe. Near black holes, for instance, time slows to a crawl under immense gravity. To an outside observer, anything falling into the event horizon appears frozen, never crossing the edge. But from the perspective of the falling object, time continues normally until it ends in singularity, where physics itself breaks down. Is this the place where time itself tears its fabric shredded by infinite density? Or is it the first hint that time cannot survive the deepest laws of nature? Others point to the early universe. At the moment of the Big Bang, time as we know it may not have existed. Before expansion, before energy and matter, before light itself, what did before even mean? If time emerged in that fiery instant, then it is not eternal. It is a phenomenon with a birth and therefore, perhaps, with an end. If time began once, it could collapse again, leaving behind only silence. The idea that time may not exist fundamentally is not confined to cosmology. Some of the most daring physicists have proposed that time is emergent, not a building block of reality, but a byproduct of something deeper. Carlo Rovelli, a pioneer of loop quantum gravity, suggests that time emerges from interactions between particles, not from any absolute background. In his view, time is relational. It exists only in the context of change, only when there is something to measure against something else. If this is true, then the breakdown of time would not be the crumbling of a cosmic clock, but the collapse of relationships themselves, the dissolution of structure into meaningless fragments. Imagine then what a breakdown of time might feel like. The seconds would not stop in a sudden jolt, like a clock freezing mid-tick. Instead, the fabric of experience would unravel gradually. Memories would bleed into anticipation. Causes would no longer lead to effects. Perhaps you would take a step forward, only to find yourself stepping back. Or perhaps you would simply dissolve into a haze where nothing can be distinguished as past or future. For us, creatures built on narrative and sequence, this would be indistinguishable from death. A death not of the body, but of reality itself. And yet, some speculate that such a breakdown may not mean the end. If time collapses, it may give rise to something else, a higher order, beyond our comprehension. Just as a two-dimensional being cannot grasp the fullness of three dimensions, perhaps we cannot grasp what lies beyond time. To us, it looks like collapse. To a higher perspective, it may look like transformation. The breakdown of time could be the moment the universe shifts into a new mode of existence, one without seconds, minutes, or hours, but with a kind of timeless symmetry. For now, though, we are trapped inside the clock, listening to its ticking, wondering if it is steady or faltering. The evidence is scattered across physics, philosophy, and cosmology, hints that the flow we take for granted is not absolute. Time is already strange, already fractured, already bending in ways we barely comprehend. The terrifying question is not whether time might someday break, but whether it is already breaking and we have not yet noticed. If time is breaking down, where should we look for its scars? Physicists often turn their gaze to the most extreme arenas of the cosmos: black holes, the Big Bang, and the expanding edges of the universe. Yet the cracks may be closer than we think, woven into the equations that govern our everyday world. One place where the unraveling of time shows itself is in quantum entanglement. Two particles, born together, can remain connected across vast distances. Measure one, and the other responds instantly, faster than light, outside the rules of cause and effect. What is striking is not just the speed, but the fact that such entangled pairs appear to exist in a shared state without reference to time. Their correlation is timeless, as if they bypass the river entirely. Einstein called it spooky action at a distance. Today, it hints at something deeper. Perhaps time itself is not the stage, but a shadow cast by a more fundamental order. Another potential fracture emerges from cosmology's grand puzzle: dark energy. Observations show that the universe is not just expanding, but accelerating outward, driven by some unseen force. This acceleration creates a horizon, a boundary beyond which light will never reach us. As the cosmos stretches, galaxies slip away, disappearing beyond this invisible edge. For observers within the universe, it is as if time itself is erasing connections, cutting off parts of reality. Some theorists worry this expansion may tear the fabric of space-time in a big rip, where every galaxy, every atom, and finally every tick of time is pulled apart. If this were to occur, time would not end in silence, but in violent dissolution, shredded by the universe's own expansion. Closer to home, physicists probe the smallest intervals imaginable, the Planck scale, where distances are so small that space and time themselves may no longer be smooth, but granular. At this level, time may flicker, jumping in discrete steps instead of flowing continuously. If so, what we experience as smooth duration may be an illusion, like a film strip where still images pass quickly enough to appear fluid. But what happens if the reel stutters, if the flicker slows, or if the sequence collapses entirely? Then time itself would no longer be a coherent thread, but a broken scatter of disconnected instants. This idea grows even more unsettling when we consider entropy and the arrow of time. Entropy's steady rise defines our sense of forward motion. Yet some theories of cosmology suggest that entropy could reset under extreme conditions, such as during cosmic bounces or collapses. Imagine a universe where disorder ceases to grow and instead reverses, where broken cups reassemble, where smoke condenses back into flame, where memories are written backward. Such a reversal would not simply confuse us, it would annihilate our sense of existence. For us, bound to the arrow of time, it would feel like the ultimate fracture, the moment the universe itself forgets how to move forward. Some scientists suggest that time's breakdown is already inscribed in black holes through Hawking radiation. Stephen Hawking revealed that black holes are not entirely black. Quantum effects allow them to emit faint radiation, causing them to evaporate slowly. Yet this poses the infamous information paradox. If a black hole swallows matter and then evaporates, what happens to the information within? Does it vanish forever, breaking the rules of quantum physics? Or does it leak out in distorted form, suggesting time inside the black hole follows a script we cannot read? In either case, black holes may be the laboratories of time's breakdown, devouring not just light and matter, but chronology itself. But perhaps the most haunting possibility is that time does not exist fundamentally, not even in the equations of the universe. Physicist Julian Barbour has argued that time is nothing more than a measure of change. The universe, in his view, is a vast collection of possible configurations, what he calls nows, What we perceive as the passage of time is merely our movement through this landscape of moments, guided by memory and perception. In this view, the breakdown of time is not an event that will come in the future, but the recognition that it never existed at all. The collapse lies not in the cosmos, but in our understanding. If true, this would mean the universe is timeless, a frozen structure in which every possible moment already exists. We experience sequence only because our consciousness stitches these fragments together like frames of a film. To realize this is to stand on the precipice of an existential abyss. The flow of time, the heartbeat of our existence, may be nothing but a trick of perspective. And yet, we live as though time is real. We measure it, fear it, cherish it. We build our lives around it, knowing that each passing second carries us closer to death. The idea that time could break down is terrifying, not only scientifically, but emotionally. It threatens to strip us of continuity, of narrative, of meaning. For without time, there is no growth, no loss, no love, no memory. There is only the endless stillness of eternity, something our finite minds cannot bear. Still, physics demands we look beyond comfort. Whether in the collapse of entropy, the rips of dark energy, the mysteries of quantum entanglement, or the paradoxes of black holes, the evidence accumulates. Time is not what it seems. It may be fragile, illusory, or emergent, and if it is already cracking, the consequences stretch beyond science into philosophy, into the heart of what it means to exist. So perhaps the true question is not whether time will break down, but whether it already has, and we are only now beginning to glimpse the cracks. If our reality is built on an unstable foundation, then every heartbeat, every breath, every memory is perched precariously on the edge of collapse. To understand this is to confront the most profound mystery of all, that existence itself may be temporary, not because of death or decay, but because the medium in which we live time may not last. And if one day the clock of the universe truly does stop, then there will be no witness to mourn its silence. There will be no after, no end. Only the quiet truth that time was never eternal, only borrowed, and that we lived within its fleeting illusion until the very moment it fell apart. Time has always been a fragile companion, but at the boundaries of reality, it grows even thinner, like glass stretched to its breaking point. Imagine standing at the edge of the observable universe, a place so far that light from those galaxies has been traveling for nearly the entire age of existence. Beyond that horizon, space continues, but its signals can never reach us. For those who live here, the cosmos is a vast theater where half the stage is hidden behind a curtain that never rises. This horizon is not just a boundary of distance, it is a boundary of time itself. Here, time begins to behave like a frayed rope. Every second that passes, the horizon stretches farther, swallowing galaxies in silence. From our vantage point, they simply fade into invisibility. Not because they no longer exist, but because time has erased our connection to them. It is as if reality itself is pulling away, stripping us of witnesses, isolating us within an ever-shrinking bubble of what can be seen, touched, or known. This is not merely expansion. It is the slow, patient fragmentation of time's continuity, cutting the threads that once bound every corner of the universe together. Physicists describe this edge as a cosmic event horizon, similar to the horizon of a black hole. Just as no light escapes a black hole's gravity, no information from beyond the cosmological horizon can reach us. For the galaxies drifting across that line, time does not end. It simply becomes inaccessible. Yet for us, their departure marks an irretrievable fracture. It is as if their future unfolds in a separate reality, one we are forever locked away from. This raises a haunting thought. If the universe continues accelerating, then eventually, even the faint glow of stars in our own neighborhood will vanish. Millions of years from now, the night sky will darken, not because stars are gone, but because their light can no longer arrive. Civilizations born in that distant era may look up and believe they are alone, imprisoned within a silent, starless void. For them, the universe will not appear infinite. It will appear claustrophobic, finite, suffocating. Time's fracture will not be a distant theory. It will be the fabric of their reality. But the horizon is not the only boundary where time breaks. At the smallest scales, deep in the mathematics of quantum mechanics, there is another fracture. One that suggests time itself may be emergent, not fundamental. In quantum gravity theories, space-time may arise from entangled networks of information. Here, time is not an arrow, but a statistical artifact born from relationships between countless particles. If those relationships fail, if the entanglement frays, then time dissolves. It does not die in fire or collapse. It simply ceases to exist, like the faint glow of a candle snuffed out by the wind. Some researchers test these ideas by examining what happens when quantum particles interact in ways that defy temporal order. In experiments, events have been created where A influences B and B influences A, without a clear before or after. In these tangled sequences, causality itself becomes uncertain. Time does not flow forward. It becomes a loop, a smear, a haze. What we call before and after lose their meaning. If such behavior exists at the quantum scale, could it extend outward, reshaping the larger universe? Could the cracks we see at horizons and singularities be reflections of a deeper truth, that time was never linear, never absolute, but always fragile? The edge of reality is not only physical, it is perceptual. Our brains are wired to experience duration as smooth, continuous, and irreversible. Memory gives us a sense of past, anticipation gives us a sense of future. But neuroscience shows these are illusions stitched together by neural rhythms. When those rhythms are disrupted in dreams, in trauma, in certain altered states of consciousness, time falters. Minutes stretch into eternities, hours vanish in a heartbeat. The breakdown of time is not only a cosmic phenomenon, it is a human one. At the edge of perception, we glimpse the fragility of the very fabric we believe to be unbreakable. If both physics and perception reveal fractures, then perhaps the breakdown of time is not a distant apocalypse, but a constant presence. Every horizon crossed, every black hole formed, every neuron misfiring is a small collapse of time. Each one whispers the same secret, that the continuity we cling to may be nothing more than a temporary construction. And if that is true, then the most terrifying possibility emerges, not that time will someday end, but that time is already ending, everywhere, all at once. The cracks are here. We simply live too quickly, too narrowly to notice. If time is already breaking down at the edges of reality, then what does this mean for the fate of the universe and for us who live within it? To answer, we must travel to the deepest paradoxes of physics, where cosmology, relativity, and quantum theory collide. Black holes remain the most haunting laboratories of time. Near their event horizons, clocks slow to a crawl, dragged by the gravity of warped spacetime. To an observer outside, time for the falling traveler seems to freeze. They never quite cross the horizon. They simply fade, stretching thinner and thinner in the eye of the beholder. But for the traveler themselves, the story is different. They cross the horizon in finite time, rushing toward the singularity where the very laws of physics collapse. This contradiction reveals the fragility of temporal experience. From one perspective, the traveler never reaches the end. From another, they are already gone. Two realities coexist, both true, both incompatible. If such contradictions exist, then perhaps time itself is not fundamental, but relational, a fragile agreement between observers that shatters under extreme conditions. Stephen Hawking famously added fuel to this paradox with his radiation theory. Black holes are not entirely black. They leak energy in the form of quantum fluctuations at their horizon. Over unimaginable eons, they evaporate. Yet here lies the dilemma. If information falls into a black hole and the black hole evaporates, where does that information go? If it is lost, then the very principle of causality breaks down. The past would no longer guarantee the present. Time's chain of cause and effect would be severed. The information paradox is not just a puzzle about black holes. It is a question about whether time itself can be trusted. If reality cannot safeguard its own history, then what is left of the arrow of time we cling to so desperately? The universe's acceleration, driven by what we call dark energy, expands space-time itself. Galaxies once close become unreachable. Their light grows redder until it vanishes beyond our horizon. For those galaxies, billions of years from now, our Milky Way will fade into the same unreachable silence. Time fractures not because events cease, but because the connection between them is destroyed. Imagine a library where half the books are locked away behind unbreakable glass. Their stories continue to unfold, but you will never read their pages again. The cosmos is slowly sealing its shelves. With every passing epoch, more is lost. This is not the destruction of time, but the compartmentalization of time into disconnected islands. Each island is a world unto itself, cut off from all others. On the quantum level, things grow even stranger. Experiments in quantum entanglement suggest that particles separated by vast distances can remain connected, their properties correlated as though no time passes between them. Here, simultaneity reappears not as a smooth flow, but as a sudden, eerie synchronicity. Some physicists argue that time, as we know it, emerges only when entanglement is broken, when systems decohere and settle into fixed states. If this is true, then time is not a river, but a collapse. It does not flow forward. It crystallizes moment by moment from an ocean of possibilities. At the deepest levels, reality may not happen at all. It may only exist as a frozen landscape of probabilities, with our consciousness stitching them into the illusion of passage. But beyond equations and telescopes, there is another frontier, the human one. Our lives are measured in fleeting instants, fragile memories, and the slow erosion of identity. We speak of time as if it is external, yet we know it only from within. When we forget, when we dream, when we fall into love or grief, time bends. A moment can hold an eternity. A year can vanish like smoke. Perhaps this is the greatest clue. If time fractures in our minds, if it bends and dissolves under the weight of perception, then why should the universe be any different? We are, after all, children of the same laws. Our inner horizons may be mirrors of the cosmic ones. As physicists push deeper, they begin to glimpse a possibility that unnerves them, that the breakdown of time is not an accident, but a feature. Time may not be fundamental at all, but a scaffolding erected by the universe to allow complexity to bloom. Once galaxies, stars, and consciousness have emerged, the scaffolding can be dismantled. Time collapses not because of failure, but because its work is complete. This perspective reshapes the question. The edge of time is not a catastrophe, it is a transition. Just as the caterpillar dissolves into chaos before becoming a butterfly, the cosmos may dissolve the flow of time to prepare for something new, a form of existence beyond duration, beyond entropy, beyond the ticking of any clock. Standing here, in this fragile moment of cosmic history, we are witnesses to the fractures. We see galaxies sliding into invisibility, black holes gnawing at causality, quantum events twisting the arrow of before and after. We feel in our bones the fleeting nature of memory, the fragility of every second. And perhaps that is the true gift. For if time is breaking down, if its edges are already unraveling, then every moment we live becomes infinitely precious. Each second is not merely a step along an endless line, but a miracle, born from a cosmos that may one day leave time behind. The question is not whether time will end, but whether we will learn to see, before it does, the beauty of its fracture. Time is not only a measurement of change, it is the canvas on which all existence is painted. Yet at the very edge of reality, the canvas appears torn, fraying into threads that leave us asking whether the flow we cling to has ever been real at all. The more deeply physicists explore these cracks, the more they are forced to admit that our human sense of time may be no more than a story, an internal narrative stitched together by perception. The cosmos may never have flowed as we imagine. Instead, what we call time could be a scaffolding, an approximation built from entropy, memory, and sequence. Remove those, and what is left is not duration, but presence, a universe that simply is, timeless, frozen, eternal. Yet in this eternal landscape, our experience of time becomes even more profound. For if continuity is an illusion, then each moment is not merely a step in a sequence, but a complete universe in itself. Every breath, every heartbeat, every sunrise contains the whole of existence, self-sufficient and irreplaceable. To see time as fragile is not to devalue it, but to deepen its significance. For what is fragile is precious, and what is fleeting is sacred. The breakdown of time is not only a cosmic question, but a human reflection. We live with time's fractures every day. Memory slips. Moments stretch and contract under the weight of emotion. Grief slows time into an endless present. Joy compresses hours into instants. Our inner clocks are as inconsistent as the cosmic ones. If physics teaches us that time unravels at horizons and singularities, our lives remind us that time unravels in the heart as well. Horizons. They are not merely exotic laboratories for physics, they are mirrors of the human condition. Just as galaxies fade beyond reach, so too do our days. Just as information seems trapped at horizons, so too do our memories become locked away, inaccessible, though never truly destroyed. And just as quantum entanglement defies causality, so too do moments of love, fear, or awe appear to transcend sequence, arriving outside the order of before and after. What emerges is a vision of time, not as a single smooth arrow, but as a fractured mosaic. Some pieces stretch, others compress, some vanish altogether, yet together they form the pattern we call reality. To live within this mosaic is to accept that continuity is an illusion, but meaning is not. The cracks in time do not erase significance, they give it depth. Physicists often ask, if time is breaking down at the edge of reality, what comes after? The answers range from silence to speculation. A universe without time, where existence is static, or a universe where new dimensions of temporality unfold beyond our comprehension. But for us, standing here, the question may be more intimate. If time breaks, what do we hold on to? The answer, perhaps, is not permanence, but presence. Not the guarantee of tomorrow, but the reality of now. If the cosmos is teaching us anything through its horizons and singularities, it is this: that every moment we inhabit is infinitely valuable precisely because it may be the only one. Eternity is not found by escaping time, but by embracing its fragility. There is also, hidden within this paradox, a strange kind of hope. If time can break, then perhaps endings are not absolute. If the arrow can bend, perhaps loss is not final. The galaxies that slip beyond our horizon are not gone, they are simply unreachable. The memories that fade are not erased, they are encoded somewhere in ways we cannot yet perceive. To believe in the breakdown of time is also to believe in the persistence of presence, even beyond our ability to witness it. And so the edge of time becomes not an apocalypse, but a threshold, a veil we do not yet understand, but one that may lead to a reality even richer, stranger, and more beautiful than the one we know. Beyond the breakdown may lie not nothingness, but transformation. Just as the death of a star gives birth to new worlds, just as collapse seeds creation, so too might the fracture of time itself give rise to forms of existence unimaginable to us. The human mind was not built to grasp such immensities. We cling to past, present, and future because they give shape to our stories, because they give comfort to our fears. But physics whispers that these are not absolutes, only approximations, shadows of deeper laws. And yet, rather than despair, this realization invites wonder. For if time is fragile, then so too is destiny. Nothing is fixed, nothing inevitable. The cracks in the cosmos may also be the cracks where freedom enters. At the edge of reality, where galaxies vanish and clocks fail, we confront not the end, but the possibility of seeing differently. To imagine that time itself may be breaking is to admit that the story of the universe is larger than we can hold. It is to accept that our categories are temporary, that our maps are incomplete, that truth is stranger than any tale we can tell. And perhaps that's the ultimate gift of physics. Not certainty, but humility. Not closure, but openness. Not answers, but better questions. So what if time itself is breaking down? Then every moment is a miracle. Then every horizon is not a prison, but a portal. Then the cracks in reality are not flaws, but invitations to think deeper, to feel more, to wonder without end. And when the night sky darkens, when galaxies drift away, when even the constellations that guided our ancestors vanish into silence, what will remain is not despair, but awe. For even in the absence of time, the universe will still be, and perhaps so will we, not as we know ourselves, but as part of a reality beyond clocks and calendars, beyond beginnings and endings, beyond the fragile illusion of time. At the edge of reality, time falters. Horizons drift beyond reach. Galaxies dissolve into silence. And even the laws we trusted bend under the weight of paradox. Yet perhaps the greatest revelation is not that time is fragile, but that fragility itself is the essence of existence. We have always lived in the fractures of time, in moments that stretch under grief, in seconds that vanish in joy, in memories that fade even as they define us. The cosmos reminds us that what we feel is not illusion, but truth, mirrored on the grandest scales. Black holes hoard memory, horizons erase connection, quantum fields blur causality, all echoes of the same fragile rhythm we carry in our lives. If time is breaking, then what endures? Not permanence, but presence. Not certainty, but wonder. Perhaps the universe has never promised continuity. Perhaps it has only ever given us instants, unrepeatable, irreplaceable, infinite in their fleetingness. In this way, the breakdown of time is not a catastrophe, but a gift. It teaches us that nothing can be taken for granted. Not the light of stars, not the bonds of memory, not the breath we draw in this moment. Each is a fragment of eternity, made precious by the possibility of its end. So, as the cosmos accelerates into silence, as horizons slip away and the arrow of time dissolves, one truth remains. The beauty of existence lies not in its permanence, but in its fragility. And perhaps, in the end, that is enough.